2.2a, I'm going to call this part 1 because I'm going to do the front of the worksheet as a part 1, and then I'm going to do the back side of the worksheet as a part 2. All right, so up to this point, you have been finding the derivative with this crazy formula. But what if I gave you a problem like this and asked you to find the derivative using this formula? And you'd have to do x plus delta x to the 4th power. So you'd have to FOIL it out and distribute 4 times like that, which would be a nightmare. It would take you a ton of paper and a ton of time. So instead of doing this, you are only going to use this formula now when you are asked for it in the directions. Okay? From now on, we're going to use a new method. Okay, a shorter method. I think an easier method than doing this. Okay, so here we go. Let's see if you can find the pattern. Okay, so here's the first function, x cubed minus 12x. When I take the derivative, it turns into 3x squared minus 12. So from here to here. All right, some of you might already have the pattern, some might not. Let's take a look at the second one. 7x to the 6th plus 5x cubed minus 6x squared. This 7x to the 6th turned into 42x to the 5th. This term turned into 15x squared. And this turned into 12x. Okay, maybe you're starting to see a pattern. All right, so let's look at this one. 8x to the 3rd turns into 24x squared. 9x to the 4th turned into 36x to the 3rd. All right, so let's take a look. See if you can come up with a pattern here. Let's look at this one. So I took this 7 times the exponent and got 42, and then I lowered it by 1. So now it's x to the 5th. This one, I multiplied these two together and got 15, and then I lowered the exponent by 1 and got squared. Here I multiplied 6 times 2 and got 12, and lowered it by 1, so now it's x to the 1st. This is the answer we would have gotten if we used this crazy formula, but look how much faster that is. All right, so here, 8 times 3 is 24. Lower it by 1, and I get it to the 2nd. 9 times 4 is 36. Lower it by 1, and I get to the 3rd. All right, so let's try these two on the bottom here. Multiply it together, so I get an 8. Lower it by 1, so it becomes x to the 1st. This has a 1, so 6 times 1 is 6. If I lower it by 1, it becomes 0, so we don't even have to write it there. When a number is by itself like this constant, it's really having an x to the 0 there. So when I do 5 times 0, I get 0, so then that wipes out that term. So any constant, when you take the derivative of it, it's going to turn into 0. All right, let's try this one here before we get to the notes. All right, multiply that together, and I get 18. X to the 5th, because I lowered it by 1. Multiply. Lower it by 1. This is a 1. Multiply. And when I lower it by 1, it just goes to 0, so there's no more x there. And then the 7 goes away. All right, so there's kind of your shortcut beginning. And now we're going to do all these examples on this front page here. Some are a little quicker than others. So here, if I take the derivative, we're going to put a little f prime of x there to let us know we're taking the derivative. Bring the 3 out front, because there's like a 1 here, right? So 3 times 1 is 3. Lower it by 1. Which, you know what, right above there, it asks for the power rule. So this is called the power rule. Your exponent gets multiplied out front, and you lower the exponent by 1. Okay, so if you need to write that down, the exponent gets moved out in front, multiplied to the coefficient that is there, and you lower the exponent by 1. All right, so there's A. Let's go down to D. All right, derivative. Lower it by 1, so it's going to be 2t to the 1st. Here there's a 1. 1 times 2 is 2. And then if I lower it by 1, it becomes 0, so I don't need to write t to the 0. 3 has a t to the 0, so when I multiply it out front, it wipes out that constant term. So there's your derivative for d. All right, so one of the rules for right now is that you can't take the derivative if there's parentheses going on. So you have to eliminate the parentheses first. Okay, so all I'm going to do here is I'm going to distribute. So if I distribute here, I get 2t to the third. I kind of luck out when I distribute here, the t's cancel and it just becomes 2 times 3. So now my g of t function is really just 2t to the third minus 6. So let's take the derivative of that. If I power this down, that becomes 6t squared. That's a constant, so that goes away. Let's go back up and pick up part B. All right, the other thing with roots is we can't take a derivative with a root. So you have to change the root to an exponent. So I'm just going to rewrite this to be x to the 1/3. All right, now I'm going to go through and take the derivative. The 1/3 goes out front. And when you write it in your note paper, it's going to be much easier if you kind of are clear that it's 1 and 3, and then up here I have an x. If I take 1/3 minus 1, that's really 1/3 minus 1 over 1, which is really 1/3 minus 3 over 3, which is going to be a negative 2/3. So notice how I wrote it. It's 1, x to the negative 2/3 is in the numerator, and 3 is in the denominator. So when I go to rewrite this, 1 gets to stay, 3 gets to stay, but this is a negative exponent, so that moves to the bottom. You don't have to put it back into a root. Leaving it x to the 2/3 as an exponent is just fine. All right, going across, let's look at C. So kind of similar to this one where I had to rewrite it with an exponent, I have to rewrite this one as well. That fraction isn't going to help me out any. So when I rewrite this, I'm going to rewrite it to be, well, 1 over x squared, I could rewrite that to be x to the negative 2nd. So being familiar with your exponent rules, when they're negatives, moves to the bottom and becomes positive. Or if it's already positive in the bottom, we can move it up and make it negative. All right, now that there's no fraction going on, now I can go ahead and take that derivative. So I move that power down in front. But now you lower it by 1. So just be careful. That becomes to the negative 1/3. Okay, so when I rewrite that, my derivative is a negative 2 stays on the top. That has to move to the bottom. Your answers always have to be written with a positive exponent. All right, as soon as I have a root, I automatically just rewrite it with an exponent. Because once I've eliminated the root, now you're okay. Now I can go through and take the derivative. So notice I've kept this f of x. I haven't done anything with that yet. I've just rewritten it. Now I'm going to take the derivative. Now I can do f prime of x. And now I can apply that power rule. So I'm going to bring that 3 down in front, becomes 6 x squared, plus 1/2 goes down in front. But 1/2 then minus 1 is going to be a negative 1/2. So when I rewrite my final answer, because your answer always has to have positive exponents, it's 6x squared plus 1 is on top, 2x to the 1/2 is on the bottom. And then that is your answer. All right, on this guy, we cannot take the derivative of fractions when we have stuff going on in the top and the bottom right now. Eventually we will be able to, but right now we can't. So we have to figure out how we're going to get rid of that fraction. Just like in letter F, we had to eliminate the parentheses for multiplying. Now we have to eliminate the division there. So I'm going to go through and rewrite this. And all I'm going to do is take that x and divide it into each part. So when I rewrite this 2x squared over x, it's really 2x because the x's cancel. 3x over x, the x's cancel, so it's really just minus 3. Here, nothing cancels, so I'm going to have 1 over x. Okay, now I'm still not there yet because I have a fraction here. So I'm going to rewrite it again. Now I have x to the negative first. Now I am good. No fractions, no division. I can go through and take that derivative. 2x is just going to turn into a 2. Minus 3 goes away. Bring the negative 1 out front and lower your exponent by 1. And now I can't have a negative exponent. So I'm going to rewrite this to be 2 minus 1 over x squared. Notice that the x squared just went under the 1 and not under the entire thing. It's only this term that the x squared is under. All right, that is part 1. I will be back in a minute with part 2.